Hello everyone, I hope you all are fine. So today we are going to discuss about basic concepts of chemistry. So earlier we have discussed about atoms, what are protons and what are electrons. Now we are going to discuss that how electrons are arranged around the nucleus of an atom. That how electrons are arranged around nucleus of the atom. This arrangement of electrons around the nucleus is also called as electronic configuration. Electronic configuration. So, this electronic configuration gives us how we can arrange the electrons around the nucleus. So, an element is having one nucleus. An element is having one nucleus, and around that nucleus there are orbits. There are different orbits, and we call these orbits as shells also. We call them as shells or orbit. So there are different orbits like K shell, L shell, then there is M shell and N shell. And in these shells the electrons are arranged. Electrons are arranged in these shells, and there is one formula which is 2n square. This formula gives us the electronic configuration of any element. N here denotes number of shell. So if we talk about first shell, so n will be equal to 1. According to this formula, 2n square to 1 square gives us 2 into 1, that is 2. So every time in first shell, that means in K shell, we can arrange only 2 electrons. Only 2 electrons here. So we can arrange only 2 electrons, and this K shell is called as duplet. This K shell is called as duplet. Then if we talk about second shell, that is n is equal to 2. So 2n square is equal to 2 whole square, which is equal to 2 into 4, that gives us 8. Means in second shell, that is L shell, we can arrange maximum of 8 electrons like this: 1, 2, 3, 4, 5, 6, 7, 8. So this is how we can arrange electrons around the nucleus in the orbits, and through this formula 2n square we can have different number of electrons in different shells elements. So I have made this table: electronic configuration, elements, number of protons which is equal to number of electrons, shells, K shell, L shell, M and N. Then next is valency. We will also discuss about that what is valency. So our first element is hydrogen. So the atomic number of hydrogen is 1, so number of proton in hydrogen is 1, and we have to arrange these electrons in these shells. As it is having only 1 electron, so it will go into K shell. Okay, now our next element is helium. The atomic number of helium is 2. So these 2 electrons will be there in K shell. As we have discussed that first is K shell, and it will only occupy 2 electrons. Our third element is lithium, and the atomic number of lithium is 3. So we are going to split this 3. So in first shell, as maximum of 2 electrons can be occupied, so 2 electrons will be there in first and then one electron will be there in the L shell. So the electronic configuration of lithium becomes 2 1 like this. So the electronic configuration of lithium is 2 1. Then our fourth, so carbon, atomic number of carbon is 6, that is number of proton will be 6 and the electronic configuration is 2 4. Nitrogen 2 5, oxygen 2 6, fluorine 2 7, neon 2 8. Then comes sodium. Sodium has atomic number 11, which means that it is electronic configuration of sodium is 281. Then magnesium 282, aluminium 283, silicon 284, phosphorus 285, sulfur 286, chlorine 287, argon 288 and potassium 2881. Now here again, maximum of 8 electrons can be there, so it reaches, so the next electron will move to another shell. Then calcium 2882. So this is how we can write the electronic configuration of different elements. Now you can see here, if we talk about helium, helium has 2 electrons in its outermost shell and it is stable. Then if we look here at neon, neon is having 2 and 8, means this element neon is also stable. Then argon 288, means argon is also stable as it don't have to lose any electron or. So this is how we write the electronic configuration of different elements. Now comes the valency. So valency is the tendency of any atom to lose or gain electron, that is to attain their stable configuration. Like I have told, helium, neon and argon, they all are stable as the outermost shells have maximum number of electrons which can be there in the outermost shell. Now for attaining stable configuration, every element can either lose the electron or it can gain the electron. So that is what the valency is. Now hydrogen. Hydrogen has only one electron. So to attain the stable electronic configuration, hydrogen can either lose this electron or it can gain. So the valency of hydrogen will be 1. Then the valency of helium will be 0 as it does not have to lose any electron or gain any electron as it is already stable. Now comes to lithium. If we talk about lithium, the outermost shell of lithium has 1 electron, means it can lose this electron so that there will be 2 electrons in its outermost shell and it can be balanced. So lithium will lose 1 electron. Okay, so now I will tell you a simple trick that how can we find the valency of any element. Now we know that outermost shell of any atom will have 1 to 8 electrons. So if the outermost shell has 1, 2, 3 or 4 electrons, then valency will remain same. Like if I talk about sodium, the atomic number of sodium is 11, so its electronic configuration is 281. Now the outermost shell has only 1 electron, so the valency of sodium will be 1. But if the outermost shell has electrons like 5, 6, 7 and 8, then we can find the valency by simply subtracting these from 8. So 8 minus electrons in outermost shell. So if the outermost shell has 5 electrons, then 8 minus 5 is equal to 3. If 6, then 8 minus 6 is equal to 2. So this is a simple trick that how can we find the valency of any element. Now if we see here, beryllium has 2 electrons in its outermost shell, so the valency of beryllium was 2. Now boron has 3, so valency will be 3. Carbon 4, valency will be 4. Now nitrogen has 5 electrons in its outermost shell, means 8 minus 5. So the valency will come out to be 3, as it has to gain 3 electrons so that it can become 8 and it will reach to its stability. So the valency of nitrogen is 3. Then oxygen 2, fluorine 1, neon 0, as it is already stable, as it does not require to lose any electron or to gain. Then the valency of sodium will be 1, magnesium 2, aluminium 3, silicon 4. Here comes again 5. So the valency of phosphorus will be 3, sulfur 2, chlorine 1, then again argon 0, as it is stable. Potassium 1 and calcium 2. So this is how we can write the valency of any element.